Assalamu alaikum. Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent and the most merciful. Guys, today I'm going to solve a question. The question is the same, to find the domain, right? So I'm going to write down the question here. The question is fx is equal to under root 1 minus 5 power x divided by 7 power minus x minus 7. This is fx. Fx is given. You have to find the domain of this one. Find the domain. Find the domain, right? You have to find the domain here. Okay. So as you can see that this function is written in a square root, right? Only the first condition that you have to see. This function is written in square root, number one. And here we have exponential function, right? This 5 power x is exponential growth and 7 power minus it is the exponential decay, right? I will tell you this one in the next video. But here now the function is given and we have to find the domain of this function, right? So as you see, how will I solve this question? The answer here, as you can see that if you have under root x, right? I told you this one in my previous lectures. If you see any square root, right? So the domain for the square root will be the x must be 0 and greater than 0, right? If you give any value of x which is 0 or greater than 0, then the y defined, right? In the same way, we have here in the square root 1 minus 5 power x divided by 7 power minus x minus 7. This must be greater than or equal to 0, right? So here we can take minus as a common, so you can write here 5 power x minus 1, and here you have 7 power minus x minus 7, and this is what, greater than or equal to 0. And if you are going to divide by minus 1, right? Divided by minus 1. In inequality, if you are going to divide by minus 1 or multiplied by minus 1, the sign of inequality changes, right? So here this minus and minus cancel. So you have 5 power x minus 1 divided by 7 power minus x minus 7, and this sign of inequality changes. This will be less than or equal to 0 divided by minus 1, 0. So now it's very easy, because now we have, this has been written in the terms of 5 power x minus 1, 7 power minus x minus 7. I want these values 0 or less than 0. Either this expression must be 0 or less than 0. Then we can just find out the domain of this one, right? I will solve this question by many ways. So if you know about the exponential function and the graph of the exponential function, in both conditions, the exponential growth as well as the exponential decay, right? I'm going to explain you first. For example, if you see 5 power x, 2 power x, 3 power x, 4 power x, okay? So the graph will be, for example, I'm going to draw graph 5 power x, right? Here I'm going to draw 5 power x. This is exponential because this value is greater than 1, right? If this value is greater than 1, like 2 power x, 3 power x, 4 power x, 5 power x, this is called exponential function, right? And I'm going to tell you the nature here. How will you draw the graph of 5 power? Can you see this one? Here, the 5 power x, right? So first of all, I want to tell you all the exponential function which was written like 2 power x, 3 power x, 4 power x, this must be always greater than 0. Means the graph of this function will be always upside. Okay, you cannot see any piece of the graph which goes down, right? So the graph of 5 power x, whatever the value of x you just give here, doesn't matter, right? Because the domain of this function is real number, right? So if you give any number, you will find the nature of 5 power x is always greater than 0. So, and one more thing, the y-intercept, right? I'm talking about the y-intercept. The y-intercept means x is equal to 0. So when you put x is equal to 0 here, you will find always 1. So you can say this one, right? You can see it here. This is plus 1, for example, right? So this is the first point I got it, okay? And if you want to find out the another point, no problem. Like for example, here in 5 power x, you can say I have 5 power x. If you say x is equal to 1, so it will be what? 5. So you can say this is what? 1. So it will be what? Near about, right? If you have 5 power x, you can say this will be a 1. So this will be, you can say 1, 2, 3, 4, and this is a 5. So you can say my 1 point is here, right? Right? So remember, whenever you are going to draw the graph, the first point is here, right? This is your y-intercept, and you just take 1 point here. Means here, if this is what? 0, you can find 1, right? And if x is equal to 1, then 5 power 1 is 5, right? So you can say this is this 2 point, and the graph always, okay? The graph will be always start from here, right? See, it's never touched to the x-axis here, you see. And then this will be always increasing function. It's always increasing functions, right? It touches this point. My art is not good. So this is the graph of, okay, this is the graph of exponential function, which is called 5 power x, right? Okay, this is the graph of this one. So you will say, if you want to see the in behavior here, you can say if x, this one, if x tends to minus infinity this side, okay, the function, the fx goes to 0, right? If this x is minus infinity, the function goes to 0. And you must know all these fundamental things. If x goes to what? Positive infinity, then the function goes to where? It's positive infinity. And if you are this side, the function is up. This is normal condition of the exponential function, which is 5 power x here, right? Okay, now here we have a transformation. 5 power x minus 1. Minus 1 is the vertical translation 1 unit down, right? So you know, it's very simple. You have 2 points, right? And here you must know about minus 1. Means 1 unit down. Means this point will go only 1 unit down. So what will be the structure? What will be the graph of this given function? Okay, so here if I just consider only this point, right? And listen, how will you understand the graph? For example, here this is 1 and this is, for example, minus 1, right? Minus 1. So you see this value will be always 0, and after the minus 1, it start going. Okay? So here, if you say this is 1 unit, so 1 unit down, so this point A becomes here, right? This become here, right? This point becomes here. Okay, after transformation, whenever you draw the graph of 5 power x minus 1, okay, so this point goes down, okay, and this is what? This is 5, so the next point will be this one. It's very simple. This one, this is 5, so this is 4. When x is equal to 1, this is 5, 5 minus 1, 4, so you have this one, right? And here, this will be a minus 1, right? So I can draw the graph here, so just write down this is, for example, this is, right? So what will happen, I know about this function very well. It's an increasing function, and we must know at least 2 points. and then we can, in the starting, this will be like a straight line, and then it will increase, right? So here, the first point here, you can see, the first point here is this one, and the second point is this one. So you can say the graph will be, marker is not working here right now, so see this, you can see here, okay, as you can see, the graph will go down like this way. So you can say this is the graph of, I'm talking about the red one, okay? This is the graph of 5 power x minus 1, right? This is the graph. I don't want 5 power x, right? I want 5 power x minus 1. So we can see, if you see the behavior of 5 power x minus 1, you can say when x is less than 0, the function has the negative value, right? Here, let's find out some nature when x is less than 0. See this one? When x is less than 0, our function, this one from here to here, this is always down. So we can say our function is what? Less than 0. And if this function is x, right? If x is greater than 0, see this side. If x is greater than 0, if we are here, the function goes up. See, x greater than 0, it goes up. So we can say the function always positive. Okay, and you know when x is equal to 0, here this is your function. If you say 0, x is 0, this is less than 0, this is greater than 0. But when we talk about x is equal to what? X is equal to 0, then we can say 5 power 0 is 1 minus 1, which is 0. So that at that time this will be 0, means when x is equal to 0, then we can say fx means 5 power x minus 1 will be 0, right? So this is the nature of this one, okay? And this is called exponential growth. Growth means increasing function, right? Okay, now we are going to talk about this one, okay? 7 power minus x. So whenever you have a number, if you have a number like 7 power x, so you can see 7 power x is exponential growth. But if you see 7 power minus x, it means now this is what? It's a decay. Okay, this will be a decreasing function. It will decrease it. Okay, so again you can just find out 2 points. The first point is always same. Even this is exponential function or exponential growth or decay, whatever it may be, right? So the y-intercept means x is 0. So when x7 is 7 power minus 0 means 7 power 0, the answer is always what? 1. So you can see this will be the first point here. If we have 7 power minus x, right? You can see here this one, right? Okay, the first point, the y-intercept, right? So this will be 7. And if you want to find out another one, you can say if x is equal to, for example, minus 1, right? So if you put minus 1 here, 7, this is what? Minus 1. So it becomes what? Minus plus 7. So you can say that another point is this is 5, this is 6, and this is 7, for example. So this, you can say my point is this one, right? So you have 2 points, you can say A and B. And after then you have to say the graph of this one, 7 power minus x, will be, normally the graph will be something decreasing function. This will be something like this one, right? So this is the graph of 7 power minus x. It will go like this one, right? But I don't want 7 power minus x. We have a transformation 7 power minus x minus 7. We have this graph, right? Just 7 power what? Minus x minus 7. Minus 7 means 7 unit down. So how many points I just draw here? A and B. Do only one thing, just draw 7 unit down. So you can say when you make 7 unit down, this is already on 7. So this point will be here, right? The point will be here. The first point. The first point will be here. And this is what? This is 1. So you can say this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, right? Okay. So you can say 7 unit down. So this point will go 1 unit. 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, and 6 unit. And this is 6 and plus 1, 7. So you can say here, this point will be translated here, right? And one point is here, you can say this is what? A dash, and you can say this is what? B dash. This is the point, and here I'm going to draw a horizontal line so that it will be convenient for you, right? So if I say just draw the graph of this one, 7 power minus 6 minus 7. So the graph will be something like this one, something like this, right? Okay, so here I'm going to erase some graph, okay? Because I want only two graph, this one, this red one, and this one. So I'm going to draw this one. Means I want to erase this part, right? So that you can understand. You can see, I just erase the parent function. Okay, I erase the parent function. So you can see I have just the graph of this one, right? This is, okay, means the first point here and here. So you can say this is the graph of, I'm going to mention here, 5 power x minus 1. Okay, and another I'm going to erase this part, right? You can say this one. So you can say we draw this one. Okay, I'm just going to make two individual graphs in a one plane, right? 5 power x minus 1 and 7 power minus x minus 7. Okay, so you can see this is the graph of what? 7 power minus x minus 7. So the graph is ready now. Okay, this is not the graph of the whole function, right? Remember this thing in your mind. I just make two graphs, one graph of this function, one graph of this function in one plane, so that you will understand everything. Okay, so now here I just find out 2 points here, right? As you can say, this is a point which is 0, and this is called what? Minus 1. We just find two point, right? Okay, so guys, I'm talking about, okay, I want the negative values, right? The negative value. Okay, if I consider a point here, if I consider here, I'm going to raise this one. If we consider this point here at x is equal to what? Minus 1, for example, right? So first of all, I want to tell you we will not consider minus 1. Why? Because if we put minus 1 here, so the denominator will be 0, which will be undefined. So we will use the open bracket, not I will use the closed bracket. Remember one thing, I'm not going to use the minus 1, right? Why? Because the minus 1, when you put here, it becomes minus minus plus, means 7 minus 7 0. If the denominator 0, it means the function does not exist. Okay, so I will use, for the minus 1, I will use the open bracket. Okay, so if I talk about the interval, which is minus infinity to minus 1, this one, right? If I talk about this one, minus infinity to minus 1. For the minus 1, we are going to use open. For infinity, always use the open bracket, right? So what will be the nature of the first one? This one, the numerator and the denominator, right? Means, look, we have two graphs, okay? So I'm going to mention this one. So this is your numerator, right? N. And this is your denominator, right? So you can see here, you can see before this one, right? I'm going to write down the first part here at minus infinity to minus 1. You have, this is your numerator, right? And this is your denominator, right? So you can say at these cases, this one, the whole thing, this one, check this one, from minus infinity to minus 1. Where is the graph here? The graph here is down, right? the graph is down. So you can say this value is negative, right? So this value is what? Negative. And from minus infinity to minus 1, what about the denominator? It's positive, the graph is up. So you can say this is what? Up. So this one is negative and this one is what? Positive. So negative, positive is always what? Negative. And I want what? The negative values. So we will say that the domain means if the domain belongs to minus infinity to minus 1, right? So whenever you are going to take minus infinity to minus 1, this is negative, this is positive, it means it's always negative. And I want the negative values or zeros, right? So I just find out the first interval minus infinity to minus 1, okay? And now we are talking about another interval, right? So minus 1 to 0. If I talk about at x is equal to at 0 means I'm talking about from minus 1 to 0. Look guys, I'm going to take 0. Why? Because if you put 0, 5 power 0 is 1, 1 minus 1, 0. So 0 divided by anything which is 0, right? So I will use this close bracket, right? And for minus 1, I told you, I'm not going to use the open close bracket. I will always use the open bracket. Okay? So if I see the nature from minus 1 to 0, right? Okay. So you can see, if we talk about minus 1 to 0, here, minus 1 to 0, right? So minus 1 to 0, if we talk about this one, minus 1 to 0, this one is your numerator, right? This numerator, the function is down, right? So this is your negative. Again, you have negative. This is negative, right? And minus 1 to 0, this is denominator, this one. Can you see this part? This is also negative because the graph is down. In this case, from minus 1 to 0, both numerator and denominator has the negative value, right? So negative, negative. So this is negative and this is negative. And negative divided by negative is always positive. It means this portion contains the positive part, right? And I don't want the positive part. I want negative or 0, right? So we will not take this part. So this will be not our domain, right? Because if I take any number from minus 1 to 0, we have positive value. So we will not take this one, right? So now we have to check here from where to where? From 0 to positive infinity, right? So the next is what? We discuss about from from where? From 0 from 0 to what? Positive infinity. And remember, for the infinity use the open bracket, and for 0 I'm going to take 0, right? Why? Because if you put 0, 5 power 0, which is 1, 1 minus 1, 0, and I want numerator 0 because this is less than or equal to 0, right? So from 0 to positive infinity, again I'm going to see the nature, right? So it's so easy. At this cases, if you say, at this case, from 0 to positive infinity, this one is numerator is up, right? The numerator functions, right? This is up, and from 0 to positive infinity, this is what? Negative. So this denominator is negative, and this is what? Positive. So you can say this one is positive, and this is what? Negative. So positive, negative is always negative, and I want the negative value. So you can say the next is from 0, and I'm going to use this bracket, right? Close bracket. From 0 to positive infinity, right? So from 0 to positive infinity, this function satisfied, right? 5 power x plus 1 divided by 5 power x minus 1 divided by 7 power minus x minus 7. So this is your domain. So this is your domain. You can see this is your domain. So if you have here, if you say from minus infinity to minus 1, okay, there's this part, no problem, okay. So domain is from minus infinity to minus 1. If you have minus infinity to minus 1, look, this function is positive, this function is negative, so the answer is always negative, and I want the negative values. Okay, when we put it, we must have negative values, right? And here, -1 to 0, both functions, this one numerator and denominator, both are down, so negative, negative, positive, I will not consider that. And the next, if we consider from 0 to positive infinity, one function is up and one function is down, it means again positive and negative, so we can say negative value. So the domain of this given function is from -infinity to -1 and 0 to positive infinity. But remember one thing in your mind, for the -1 I am not going to use the close bracket. The reason is I don't want -1, because if I put the -1 in the denominator, the function does not exist. Okay, so don't take -1. And why I have taken the 0? Because if I put 0, the numerator becomes 0, and I want this function 0 or less than 0. So the real domain of this function is this one. I hope guys you all understand. Please watch this video 2 times or 3 times. You feel that this question is so complicated, but when you draw the graphs and try to understand the concept of exponential function, the bottom, the growth and the decay, inshallah you will not face any problem. Take care. Bye bye. Assalamu alaikum.